This video is going to explain how to solve quadratics by square roots. When solving by square roots, there should always be two answers. When you take the square root of a value, you should have plus or minus with your answers. What this really means is that if I were to ask what is the square root of 25, your answer would just be 5. But when you have to take the inverse of a square by taking the square root, you'll end up with two answers. For example, if it was x squared equals 25, the question is really asking what squared will give you 25. And both positive 5 squared and negative 5 squared would give you a positive 25. That's why we must have a plus or minus with our answer. What we want to do is make sure when to use square roots. The best way to determine if you should use square roots or another method, so square roots is when you have one x in the problem. When you have one x. Now that means one letter x. You literally have the letter x written one time in the problem. So that could mean that you have it in vertex form when there's only one x in the problem. It could be when you have no bx term in the problem and you just have the ax squared in this c. You want to get the x by itself, and since there's only one letter x in the problem, square roots would be the best way to do this. Now when we're solving by square roots, we still want to get the x by itself, so we still need to do PEMDAS backwards. So another way of saying that is SADMEP. It's the order of operations, but we're going to do them backwards because we're solving instead of just simplifying. So our first example is 2 parentheses x plus 3 parentheses squared minus 8 equals 0. Now this is actually written in vertex form. This is a quadratic. Our a value is 2, and our vertex was at -3 and -8. So what we want to do, there's only one letter x in this problem, and that's what we want to solve for. I want to be able to get this x value completely alone. Now, some people will think that you need to distribute this too. That would be a bad idea because, one, you'd be putting more onto the x when we want to get everything away from it, but also because it's squared. It is not just 2 times all of this. You have to actually think about the fact that it is being squared. This is x plus 3 written twice. Again, you don't want to rewrite this out twice because then now you'd have 2 letter x's. So we want to use this equation and solve for this x right now. So we want to add and subtract away from our x first. There's a 2, a 3, a square, and a -8 all attached to that x. Now the 2 was multiplied, so we know we can't do that until here. This 2 was an exponent, so we know we can't do anything with that yet. And then we have this 3 and -8. Now the 3 is added and the 8 is subtracted from it. So those would be the 2 that you would think about. However, this 3 is actually inside the parentheses, and we cannot touch it until we get to the parentheses. So the only number that we can work with is this -8 because it's actually subtracted to it right now. So to undo that subtraction, we do the inverse operation, which is addition. So we're going to add 8 to both sides of our equation. And we'll be left with 2 parentheses x plus 3 parentheses squared equals a +8. Now I still want to get this x alone. I haven't done anything with that x yet. I still have a number 2, a 3, and a squared attached to my x, which I need to make sure we get rid of. So we've added and subtracted that 8 away from there, so now we can go to the division and multiplication. This 2 value is multiplied to the parentheses, and again, we're not going to distribute because that would just put more onto that x. I want to get everything away from it. So this is 2 is multiplied to this set of parentheses, so in order to undo multiplication, do the inverse operation, which is division. So I'm going to divide both sides by the value of 2. Because this is multiplied by 2 and now we're dividing this by 2, we're going to be able to get rid of these 2's. 2 divided by 2 is a 1. So we're going to be left with the parentheses x plus 3 parentheses squared equals 8 divided by 2 is 4. We still have not gotten this x alone yet, so we got to keep going. We've done the division and multiplication. Now we look for exponents. There is an exponent on this problem. We have a square. The inverse operation of squaring is square rooting. So I'm going to rewrite this problem. I'm going to keep this in blue for a moment. I'm going to rewrite it down below it so I can see what we're going to do with the problem. X plus 3 squared equals 4. Because what we need to do is to get rid of the square, we have to take the square root of this problem. Now the square root and the square are inverses of each other, so that means that these will cancel each other out. And we'll be left with the x plus 3. Now the square was attached to the parentheses, so we can get rid of the parentheses because it's going away with the square root. So we'll have x plus 3 equals. Now because we are dealing with the square root, we just took the square root. When you take the square root of a value, you should have plus or minus with your answers. We just took the square root of the value of 4. That means that we have to have that plus or minus in front of our value. Now the square root of 4 is the value of 2. We have actually just gotten rid of the parentheses. We have no parentheses left in this problem. We still have this value of x that we need to solve for. So now we start back over with our SADMAP with our order of operations backwards. We want to add or subtract away from our x. Now that 3 we can get rid of now because it is attached to that x and it's no longer inside the parentheses. So what we want to do is subtract that 3 to both sides. Now you must be careful when you write this out. I'm going to write this out in 2 different ways because we have that plus or minus. We're going to have x equals. Now that negative 3 is what we just moved over. We have to keep that plus or minus with the 2. We can't change that around. So I actually want to keep that negative 3 in the front because that's what we just moved over. And it's going to be plus or minus 2. So we're going to have plus 2. And then we'll have x equals negative 3 minus 2. Because what this really turned out to be, I'll put it over here, is x equals negative 3. Again, that was in the front because that's what we just moved over. Plus or minus 2. And then separating them, the only thing that changes is the plus or the minus. So the problem becomes negative 3 plus 2 and then negative 3 minus 2. Now that we have them separated, these are just rational numbers, so we can combine them. So negative 3 plus 2, x is equal to negative 1. Then we have negative 3 minus 2, so that's x equals negative 5. Now before we say that we're finished, we must check our answers back in the original problem. So I'm going to make a little note over here. Check answers back in original problem. We do the original because in case we ever messed up, the original problem would be accurate. So everywhere we see an x, we're going to put one of our values. Now we're going to do one at a time. So I'm going to get my calculator out. My first answer is negative 1, so we're going to use negative 1. This is 2 parentheses. X was negative 1, so I'm plugging in negative 1. Then plus 3 parentheses squared. Then minus 8. And when I press enter, it should equal to 0. It does. So negative 1 is the correct answer. I'm going to do the same thing with negative 5. So I'm going to go back up here and do 2 parentheses. X is negative 5, so I'm putting in negative 5 plus 3 parentheses squared, then minus 8. And again, this one should give me 0 as well. It does. It gives me 0 because it's supposed to equal to 0. Now, if this had said equal to 5, then my answer would have been 5. I just always have to check to make sure that this side is what it tells me on my calculator. That means that both of our answers do in fact work. So I can box them up saying our solutions are x equals negative 1 and x equals negative 5. This is when the problem is written in vertex form. There is much more math involved in this one, but you won't always be given this type of format. It could be, again, this was vertex form. This is why there's only one letter x in the problem, but it could be that it's in standard form, but it does not have the bx. So for this examples, we're going to solve the following. So again, solve means x equals. Whenever you see solve, that means x equals. This equation, 5x squared minus 180 equals 0, is written in standard form. It's just that it has a 0 bx. So we still only have one letter x in the problem. So if I highlight this x, I want to make sure we get this one single x by itself. In order to do this, we again do order of operations backwards. So we want to add and subtract away first. Now since there are no parentheses, this will make things a little bit easier. First what we want to do is we want to move this negative 180, so the inverse operation of that is adding. We have a 5 times an x, we have the squared attached to it, but then we have minus 180. That's why we focus on that part first. We're going to add the 180 to both sides, so we'll end up having 5x squared equals a positive 180, because I added the 180 to the other side. We still want to get this x by itself. We still have the 5 and the squared attached to it. The 5 is multiplied to it. That means we want to do the inverse operation of multiplication, which is division. So we're going to divide both sides by 5. We'll have x squared equals 180 divided by 5 is 36. Now in order to finish this problem, we still have that squared attached to that x. And the inverse operation of squaring is square rooting. So I'm going to rewrite this problem, x squared equals 36, so that we can take the square root. So I take square root of both sides, because that's the inverse of squaring. Now the square root of x squared, because the square and the square root are inverses of each other, this will become just x equals. Since we're taking the square root of a value, we have to remember to put our plus or minus in front of the value that we end up getting. So the square root of 36 is just 6. And again, the problem is really asking what squared gives you 36. 6 times 6 is equal to a positive 36. And negative 6 times negative 6 also gives you a positive 36. So actually, our two answers, we can write it as x equals plus or minus 6 because our x is finally alone. However, you can say that x is equal to positive 6 and x is equal to negative 6. Now I do want to check this back in my original answer, or my original problem. So I get my calculator. The problem is 5x squared minus 180. Now because I have something attached to the x, I want to use parentheses around it. So I have 5 parentheses. I want to use the 6 inside of it, parentheses squared, minus 180. Now because the right hand side says equal to 0, my answer in the calculator should be 0. It is. So that means that positive 6 does work. Now I'll do the same thing with the negative 6. We'll have 5 parentheses, we're typing in negative 6 for the x, close parentheses, squared, minus 180. And it should be equal to 0 when I hit my enter on my calculator, because that's what the problem says, and it does. Therefore, our two answers are 6 and negative 6. Again, this is when you have ax squared plus c. You only have still one letter x in the problem. On this next problem, we have 3x squared equals 24. It is not necessary to put the problem into standard form because we're solving for x. Because if we were to put it back in standard form, we'd move the 24. But then we'd have to go back again. So standard form is not necessary for this problem. We just have to get that x alone. So I'm going to highlight this x because that is the one letter x in the problem that we want to get rid of, that we want to solve for. The numbers that are attached to it are the 3 and the squared. Now the 3 is multiplied to it, and the square is an exponent. We have to get rid of the multiplication before we can do the exponent because we're solving. So to get rid of the 3 on it, that's a multiplication of 3, we're going to divide both sides by 3. We'll be left with x squared equals 24 divided by 3 is 8. Now we have this x still not alone yet. So what we want to do is we have to get rid of that square. So I'm going to rewrite this problem. X squared equals 8. Because in order to undo a square, we square root both sides. Square root, square root. The square root of x squared will be x equals. We are taking the square root of a value, so we must put our plus or minus in front of it. Now the square root of 8 is not a perfect square, so we're going to have the square root of 8 left over. And this is when we have to use our calculator. So we have the square root of 8. We're going to round it to the nearest whole number, to the nearest hundredth. We get approximately 2 and 83 hundredths. That 8, this 8 value right here will make this 2 go to a 3. So it's 2 and 83 hundredths. Now, if we did the negative square root of 8, because we had the positive, then we have the negative. We'll have the negative 2 and 83 hundredths. So in this case, we could actually just say our answer is x is approximately plus or minus 2 and 83 hundredths. So again, what that means is we have x is approximately positive 2 and 83 hundredths, and x is approximately negative 2 and 83 hundredths. Now, since we are rounding, our answers will be slightly off. So I will type in these values, but our answer will not be completely 24. It'll be close to it, but because we are rounding it, we're not going to have an exact answer, which is one of the reasons why rounding is not always the best idea. So we're going to have 3 parentheses, positive 2 and 83 hundredths squared. And that's the rest. That's it on the left. Now, it should equal to a 24, but again, it will be slightly off. It's equal to a 24 with some change. Okay. So that one is roughly accurate. So we're going to say that, yes, we were correct on our assumption that this is our answer. We're going to do the same thing with 3 times negative 2 and 83 hundredths squared. And it should, again, equal to some type of close to 24. And it does. It actually gives us the same value with the same change left over. Now, if I really wanted to check it, I could actually put in the square root of 8 instead of my x, because that was what was left over. If I actually do 3 times the square root of 8, then close my parentheses squared, I should get an exact 24. So that means that this was the correct value. This was an exact answer versus a rounded answer. I did 3 times negative square root of 8, and then I'll close my parentheses, squared. That will also give me a positive 24. So again, the plus or minus the square root of 8 is the exact answer. However, for this, we're just going to round it to the nearest hundredth since it is a radical. So that means that our answer is correct. And you can write it as plus or minus 2 and 83 hundredths. You do not have to separate them. But these are what they are as if they are separated. The next problem we're going to do goes back to making it look like vertex form. Because we have the 2 parentheses 2x plus 1 squared minus 4 equals 6. We're still going to do order of operations backwards so that we can solve. So again, we want to figure out how many x's. We have one letter x in our problem. So that means that we want to solve for that one x. We want to add and subtract away. We have this 2 multiplied to the entire parentheses, this 2 attached to the x inside, the 1 attached inside, the squared, and the minus 4. And again, it does not need to be in standard form. It does not have to be equal to 0 for us to do this problem. Now, the 2 attached to the x and the 1, we cannot touch until we get to inside the parentheses. So everything in here is going to stay the same because we have to undo the square before we can get inside of the parentheses. So we want to add and subtract away first. So the only thing that's added or subtracted right now is this 4 because I can't touch anything in the parentheses. So we're going to add that 4 to the other side first. Add 4 to both sides. So we'll be left with 2 parentheses, 2 times x plus 1 parentheses squared equals 6 plus 4 is a positive 10. We still have this x that we need to solve for. Again, inside the parentheses we can't do anything about. So now attached to it is that 2 times To undo that, to do the inverse operation of times, we divide both sides by 2. We're left with parentheses 2x plus 1 parentheses squared equals a positive 5. We still are looking for this value of x. We still have just that one letter x in there. So now the only thing attached to parentheses is the squares. The inverse operation of squaring is square root. I'm going to rewrite this problem. 2x plus 1 parentheses squared equals 5. So that we can square root both sides. Okay. Now the square and the square root are inverses of each other, so we can actually get rid of those, and that will actually get rid of the parentheses as well, because the square is attached to the parentheses. So we have 2x plus 1 is equal to, since we have the square root of a value, we have to make sure we put that plus or minus in front of that. 5 is not a perfect square, so we're just going to leave it as the square root of 5. Now, for right now, we're not going to change that to a decimal, because we want to be able to use, we will change it to a decimal in our final answer, but as of right now, using decimals will be a little tricky. And I want you to understand how to get this back into the values with the remaining radicals. So what we want to do is, now that we still have this x, we got to solve for it. Now we actually start back over with our order of operations. We're going to add and subtract away. So our x, we have a 2 times an x and a plus 1. So we want to subtract that subtract the 1 from both sides. Now when we do this, the negative 1 is actually a rational number, and the square root of 5 is irrational. We want to keep the rational number in front and the irrational number in the back, because that plus or minus has to stay with the square root of 5. So we're actually going to have 2x equals, because that's just what's left over on this side. Whatever we just moved over, that negative 1, the rational number will stay in the front of the plus or minus. And then we'll keep the irrational number in the back. Now we're almost done. We still want to get this x value by itself, which is still times 2, times by 2. So in order to undo that multiplication of 2, we're going to divide both sides by 2. We have to divide this entire side by 2. So we will be left with x equals negative 1 plus or minus the square root of 5, and this is all over 2. Now we can separate this. This is very similar to if you had seen the quadratic formula. This is what it almost looks like with the quadratic formula. We're going to separate these into 2 values so that we can plug them into our calculator to get our decimal values. Everything stays the same except for this plus or minus. This is what gives us our 2 answers. So we'll have x equals negative 1 plus the square root of 5 all over 2. Then we'll have x equals negative 1 minus the square root of 5 all over 2. Now it's just a matter of plugging into our calculator and getting our value. So if I go to my calculator, I'm going to do this first one. I'm going to do the entire numerator first. So I have negative 1 plus the square root of 5. And then I'll press enter. Then I divide by 2. I have to remember to do the denominator. So my first answer is x is approximately 62 hundredths, because that 8 makes the 1 go to a 2. So x is approximately 62 hundredths. 0 and 62 hundredths. Now to do the next one, if you have, I'll do it with the newer calculator. So if you have the newer calculator, you can actually press alpha y equals to the top one. And you can actually put it in as a fraction. So I'll put the negative 1 minus the square root of 5 on the numerator, and then I'll go ahead and go to the denominator and put 2. So I have it all in one part. I'll press enter, and it gives us negative 1 and 62 hundredths. So negative 1 and 62 hundredths. X is approximately negative 1 and 62 hundredths. Now, since we rounded it, we do want to go back to the original problem and plug it in. But since we rounded it, it will not equal to the exact value of what we want, but it should give us really close to our answer. So what we want to do is plug it back to the original. One of the things is, because the x is attached to a 2 again, I have to put an extra set of parentheses. So we have 2 parentheses, 2. Then because we have an x, I'm going to put parentheses around my x. I'm going to put in that 62 hundredths, 0.62. That's the end of my x, so I'm going to close that one set of parentheses. Then I'm going to put plus 1. Then I have a closed parentheses, squared, minus 4. Now, when I press enter, it should equal to 6 or close to it since it's a rounded answer. And it is 6 with some change. So that one is pretty accurate because we are using rounded answers. Now we're going to do the same thing with the negative 1 and 62 hundredths. So again, I'm going to put 2 parentheses, 2. There's an x, I'm going to put parentheses around my x, and we're going to type in negative 1 and 62 hundredths. That's the end of the x. I'm going to close that parenthesis for the x. I'll put plus 1. And I have to close the parentheses for the problem. Squared, minus 4. And again, it should give me something close to 6 when I answer it. And it does, and it gives me, both of these are actually the same value, so we know that these two should be pretty accurate. Again, it is rounded, so our answer is not going to be 100% accurate. If we were to have used this value, the negative 1 plus the square root of 5 all over 2, we would have gotten an exact 6. But because these are exact answers, right here, these are exact answers, these are rounded answers. That's why that happens. The last problem we're going to look at goes back to x squared minus 1/4. Just because there's a fraction doesn't mean anything weird. This still has one letter x in our problem. We want to still solve for this one letter x. So we just want to do order of operations backwards. We want to use square roots because there's no bx term. Order of operations, we want to add and subtract away first. So we have a square and then a minus 1/4. We want to add that 1/4 to the other side. So we end up with x squared equals a positive 1/4. We're still needing to get this x by itself. So we need to square root the problem to be able to get our x by itself. So I'm going to rewrite this problem. X squared equals 1/4. And then I will square root both sides. The square root of x squared will just give us an x equals. Since we're taking the square root of a value, we have to put that plus or minus. Now we have to see if the square root of 1/4 can simplify. When you're talking about fractions, you look to see your numerator, and then you take the square root of your denominator. So we actually do 2 different square roots. So we have the square root of 1. The square root of 1 is 1, so I can just put a 1 here, over. Then we take the square root of 4. The square root of 4 is just 2, so we put a 2. So actually this becomes just plus or minus 1/2. So our answer is equal to x equals plus or minus 1/2. And again, you can write it out as x equals positive 1/2 and then x equals negative 1/2. We still want to make sure we use our calculator to check it. So we have the original x. Because this letter, I do want to put parentheses. I'm going to put the 1 divided by 2, close parentheses, because that's the end of my x, squared, minus 1/4 is a fraction, so I'm going to put parentheses 1 divided by 4, because it's a fraction. And when I press enter, it should give me 0. And it does. So positive 1/2 does work. I'm going to do the same thing with the negative 1/2. This time, I'm going to use the newer calculator so I can show you the alpha y equals. So parentheses, alpha y equals, the first one. I'm going to put that negative 1 over 2. Then I'll go over and close my parentheses. Squared minus, since I can put this into alpha y equals, so I can put it into a fraction, I don't need to put my parentheses around it like I did on the first time, because I can actually keep this as a fraction and keep everything contained. So then I'll press enter, and it should give me 0 again, and it does. Now on this one, you can see that the negative is with the 1. I could have done parentheses negative, then alpha y equals 1 over 2 minus alpha y equals 1 over 4. And I should get the same. I'm sorry, I forgot to do the squared. So I'm going to go grab that and put the squared attached to it. And then I'll press enter, and it does give me 0. So then our two answers are x equals positive 1/2 and x equals negative 1/2. So plus or minus 1/2. Again, you can keep them separated, but you can just write them as plus or minus 1/2. This was what gives you your two answers, the plus or minus. So square roots, you should always have two answers, but you're not trying to factor it. You're not trying to get into standard form. You're just trying to get everything away from the x, just like a normal basic equation.